Hello everyone, today is day 46 of solving a LeetCode problem every day, and today I'm going to solve contains duplicates 2. So given an integer array nums and an integer k, return true if there are two distinct indices I and j in the array such that nums I is equal to nums j and the absolute value of I minus j is less than or equal to k. So basically all this part is saying right here is that I and j can at most be k elements apart, and then nums I is equal to nums j is just saying that the two integers at both these indexes must be equal to each other. So basically this is the same problem as contains duplicate 1, where in contain duplicate 1 we just have to see if there are two integers within the same array that are equals to each other. But the second problem gives us the constraint that these two integers must be at most k elements away from each other. So we just have to kind of add that into the algorithm. So to start off, the way you solve contain duplicate 1 is you can just create a set, and then you iterate through the array, and you add each element into the set. And if at any point, so for example, we iterate through this array right here, we add 1, we add 2, we add 3, but we're at 1 here, and we can see that we already added 1 to the set. So since we already added 1 to the set, we know that there's a duplicate within this array. So that's how you kind of solve the simpler problem. But for this contains duplicate 2, we actually also have to keep track of the actual indices. So we need to know what I and j are. So we can't use a set. We have to use a dictionary instead, because a dictionary would allow us, or a hash map would allow us to have key value pairs instead of just storing a key. So the first thing I'm going to do is start out by just creating that dictionary, and we're just going to call it past. We're then going to loop through all the integers within nums, and we're going to check if this current integer is already within our dictionary. And what we're also going to do every iteration is we're going to set within past, or within our dictionary, we're going to set nums of I to just be whatever the current index is, so we can keep track of the index. So another thing I want to mention is that we don't actually need to keep track of like every single occurrence. So for example, within nums here, we have a 1 here, or that's a bad example. This is a better example. So within the ones here, we don't actually care about this 1 over here. We only care about these 2 1s. So basically what I'm trying to say is, since we're iterating from left to right, once we do this calculation right here of abs I minus j, so this would be, we have index 0 and we have index 2. 2 minus 0 is not less than or equal to k. So what we can actually do is completely ignore this 1 here and forget about it, and just update the index in our dictionary to be this 1. Because like I said earlier, we're traversing from left to right. So since we found out that this one and this one are not compatible, so they don't, so these cases would not be true for these 2 1s right here. We know that for any 1s after this one, it can't be the case. It would be impossible, since the difference or the distance between those 2 indices are just going to become greater. So what we're going to do is we're going to update the value in past to be this index, and now we can compare this one with any future ones, which is why we are just updating the index over here. So we're setting past of nums of I to just be I, instead of, for example, storing this as a list of integers. So that's that. So now we check if nums I is in past. If it's in past, we're gonna grab the index out of the hash map, and then we're going to also, or no, we don't need to do that. So then we're just going to basically check if current index is less, and if current index minus index, so the distance between these 2 elements, are less than or equal to k. And if that is true, we can just return true. So another thing I want to mention is you might want to, so it says here There are two distinct indices I and j in the array, such that the absolute value of I minus j has to be less than or equal to k. But you might want to ask, like, or you might think, like, why am I just checking current index minus index? Or yes, like, why am I just checking if current index minus index is less than or equal to k? Why am I not also checking if index minus current index is also equal to k? And the reason is because we don't really have to, since we always know that current index is going to come after index. So for example, let's see, with over here, for example, if we have 0, 1, and 2, so this is index 2, this is index 3, 2 minus 3 is just going to give us -1. And if we take the absolute value of that, that's just going to be 1. But basically what I'm trying to say is current index is always going to be after index. And if we were to flip this around, we would then need to take the absolute value, since we'd end up with a negative number. But current index minus index is always going to give us a positive number, since current index is always going to come after index. So because of that fact, we don't have to actually take the absolute value of this. We can just return true. So finally, if we go through all the iterations, we don't return true at any point. We can just return false. And now if I submit this or run this, so it says name num is not defined. Did he mean nums? That's what I meant. And current, okay, so I just meant I here, because I is our current index. So accepted, let me submit it. And it's passed. So the time complexity to the solution is going to be O of n. And the reason why is we just have one single loop to iterate through all the integers within nums. And then all the operations within here take constant time, so we don't have to worry about this. So it's just going to run in linear time. As for space complexity, it's going to be linear too, since we may have to store every single integer within this past dictionary. They're all unique. So yeah, that's my solution for the day.